2-3 notes. Elimination using addition. Elimination is just another way to determine a solution, which is a method of solving a system of equations in which equations are added together to eliminate one variable. Again, you'll have some steps here that you can follow, and you can refer back to these steps. Step 1 is to write the system of equations so that like terms are aligned. That's the big one. And then these other steps will kind of, you'll see how they come into play here through some of these examples. So you'll have those to refer to. First equation, you have your two equations here. The biggest thing, again, is step 1, which I mentioned, is that your like terms, step 1, are aligned. So your x's are aligned and your y's are aligned. Basically, when this happens, the next thing that you want to look for is that there is a variable that we're able to eliminate, meaning that there's some opposites. For instance, if you added 6 and 3, it's not going to eliminate it. However, we have a negative 7y and a positive 7y. That would be eliminated. So if I added these two together, I would get 3x plus 6x would give me 9x. Negative 7 plus positive 7 would cancel out. There's the elimination piece. We have negative 11 plus 20, which is positive 9. Next step that you would need to take is to get x alone. So divide both sides by 9, finding out x was equal 1. Okay. Using this solution, as you've done in the past with substitution, you're simply going to plug it in for one of the equations. Okay, you can plug it into either equation. So if you choose to use the first equation that we have up here, 3x minus 7y equals negative 11. We're going to substitute 1 in for x. So we have 3, parenthesis in for x is 1. Negative 7y equals negative 11. We have 3 times 1 will give us 3. Minus 7y equals negative 11. We need to subtract 3 from both sides, giving us negative 7y equals negative 14. Get y alone, we are going to divide by negative 7, giving us y equals 2. So our solution is 1, 2. We'll go ahead and check out example 2 here. Again, making sure that our variables, our like variables, align, in which they do. Notice here that obviously it looks like the 4's here that we'd want to get rid of. However, they're both negative. So if we added them, that would not get rid of them. What I would do here is I would go ahead and I want to make one of these positive. So I'm going to go ahead and multiply this equation by negative 1. I'm just going to slide this equation over here for the purpose of making my equations line up. So now I go ahead, once I slid that equation over, I'm going to go ahead and distribute my negative 1. So negative 4x times negative 1 would give me a positive 4x. Positive 3y times negative 1 is a negative 3y. Positive, or negative 17 times a negative 1 would give me a positive 17. So here's our two equations. Again, variables lining up, and we're able to eliminate here negative 4x and positive 4x, giving us negative 13y on this side. 22 plus 17 is 39. get your y value alone, we're going to divide by 13 to both sides, giving us y is equivalent to negative 3. Now that we've solved for y, simply substitute back into one of your equations up here. And I normally like to substitute into the equation that I did not tamper with or change at all. And that's the negative 4x minus 10y equals 22. So substitute negative 3 in for y. We have negative 4x, negative 10. In for y goes negative 3 equals 22. Negative 4x. Negative 10 times negative 3 is a positive 30 equals 22. Subtract 30 from both sides. And we get negative 4x equals negative 8. 22 minus 30 divided by negative 4. And we get x equals 2. Our solution to this problem or the point of intersection would be 2, negative 3.